Hi there, welcome back to the Seaborn series of tutorials. Today we're going to be talking about ECDF, or Empirical Cumulative Distribution Function. So if you remember, we talked about histograms, and my explanation to you was that we use histograms to understand the structure in the data. So the example I gave was the neighborhood, and imagine you have 500 neighbors. You're trying to understand what is the age range of people who are living around you. And based on that, you can make a histogram like this image on this screen that I'm showing right now. I don't have 500 neighbors in this example. I only have 80 people. This is only for a demonstration. So ranging from the age of 0 to 100, I'm trying to understand, are the people living in my neighborhood young, or are they generally old or middle-aged? So from what I can see, there are a good number of people between 0 and 20, between 20 and probably 60, again, a good population. But between 80 and 95, there are not many people. However, there are a couple of people who are between 95 to 100. So this is an example. I was just trying to show you what a histogram does. So just to make it simple to explain the ECDF, or Empirical Cumulative Distribution Function, I'm going to drop the number of neighbors to 5 people. So imagine there are only 5 people. There is one person who is at the age of 8 years old. One person is 27. One person is 57. Another one's 69. And another person 75. If I draw, let me just uncomment the lines for ECDF because I'm plotting ECDF and I'm going to show you how to do it. But for now, let's look at the ECDF of this data. So 5 people, one of them under 10, one of them under 30, and so forth. What ECDF does for the number of people in this example, it just goes one step higher. So how many people are under 10? There is one person who is under 10. How many people are in total? 5 people in total. 1 over 5 equals 20%, or 0.2. The graph will go up 0.2. Then from the age of 10 to 27, there is no one. It will continue like a step function. And there is one person that is at the age of 27. So at that mark, it again goes up by 0.2. What is the reason? The reason is because there is one person out of 5 people. So 1 over 5 will be 0.2. And continues all the way to age of 57 and goes up by another 0.2. Let's consider 10 people. So the histogram looks like this. 10 people, one person just under 10, another person, another 2 people, probably 12 years old because they are on the same bar. For this person, that is only 1 out of how many people? 10 people. So 1 over 10, or 0.1. So the ECDF goes up by 0.1. The second bar, there are 2 people within this range. They can be both 11 years old, one of them 11, one of them 12, one of them 11, one of them 13, doesn't matter. They are on the same histogram bar. Let's go down. How many people are there? 2 people out of how many? 10. So 2 over 10 will be 0.2 if they are both exactly the same age. Otherwise, 0.1 and 0.1. Let's look at this. Yes, they are in different ages. For example, one of them is 11, one of them is 12. That's why we have 0.1 increase on the y-axis, and just a little later, another 0.1 increase on the y-axis. The next person is around 18 or 19 years old. So the graph continues, and at the age of 18 or 19 goes up by 0.1. That's the idea behind cumulative distribution functions. So ECDF, or cumulative distribution functions, represents the proportions that fall below a number in the graph. For example, if you want to understand what percentage of people fall below 60 years of age, so I can easily read it from here and I can tell you 70% of people in this neighborhood are under 60. So what is the advantage over a histogram or a kernel density estimation? The direct advantage is that every observation can be studied individually. The other advantage of cumulative distribution functions is that allows you to compare distributions of populations against each other. What I did now, I renamed this notebook to ECDF Dummy Data Example. I'll put the link down in the description. So if you want to follow along with me, feel free to download the data and the code from my GitHub repository. The link is in the description. And before we go on, if you enjoy this video and you like my content, please subscribe to my channel and help this channel grow. If you've been a part of this channel's viewer from previous videos, you would remember this plot. Let me run you through really quickly. Seaborn has a flat structure, has 3 main functions. However, it has also subfunctions that we can use. But for now, because we're talking about distributions, I'm going to use the DISPLOT to make an ECDF plot, but I also will show you how to use the ECDF plot function to do that. They're the same thing, but different way of doing it. Let's make a new Jupyter notebook. Let's rename it like always, Seaborn _ number 5, and this is on ECDF. Import Seaborn as SNS, import numpy as np in case we need it. If you haven't seen my previous videos, I should tell you that Seaborn has a lot of free datasets for us to use. So you don't really need to bring your own dataset. If you have your dataset, feel free to use it. But for now, I'm going to use the tips dataset from Seaborn load dataset function, and the data itself is called tips. So if I show you the first top rows of the tips data, there is the total bill amount, so how much people spent in this restaurant, the amount of tip they paid to the waiter or waitress, what were the sex of the person who paid, were they a smoker or not, which day did they come in, was that for lunch or dinner, and what was the guest size, how many people were dining. I'm going to first use the DISPLOT function, which is my favorite because it allows more flexibility in what you want to do. And I'm going to tell you why. sns.displot, the data is the tips data that I made up here, and I want the x variable to be total bill. So you will see that right off the bat, it will give me a histogram. The default plot for the DISPLOT function is a histogram. People spend somewhere from $2 all the way to $51 in this restaurant, and I can easily show the histogram using the DISPLOT function. However, if I wanted to get the ECDF, I just need to set the kind to ECDF. Again, I can see that people spend somewhere from $2-3 all the way to $51, and this is the ECDF plot. Let me just go back and set this back to hist. You will see that a lot of people spend somewhere under $25, which means that when I look at the ECDF plot, it should quickly go up before 25 and start flattening out. Let's see that. ECDF. You can see that before 25, it goes pretty steeply high. And then from 25 onwards, it starts to plateau. And the reason for that is what you can see in the histogram, because a lot of data lives here, and then there are outliers on the higher side. Moving it back to ECDF, what are the things that I can change? Well, I can change the color to red if I wanted to. I can change the line width to 4 if I wanted to. Let's get rid of the color. I want to make different colors for different classes. I know that I have categories of sex, so male and female. I can make one for males and one for females, and I can make one for smokers and non-smokers. If you've been following my previous videos, you will remember that these top level functions of Seaborn are really cool because you can easily use one line of code and produce several plots. Let's move the line width to the second line because I don't want it to be up there. And I want to say, I want you to make 2 columns of plots, and I want you to separate them based on sex. So now I have an ECDF plot for the male population, and I have an ECDF plot for the female population. Well, I am not really getting different colors. So what about setting the color, which is the hue, to be sex? That will give me different colors, blue for male and orange for female. If I wanted them to be plotted over each other, I will just get rid of the column and say, I just want you to put them in 2 different colors. I want 1 plot and 2 graphs on 1 plot. Let's bring the color parameter back again. And I want to separate the time now. I want to understand what is going on during lunch and what is going on during dinner. Are people spending more money during lunch or dinner time? Now I have one for lunch and I have one for dinner. I can see that during lunchtime, the highest bill goes about $42 to $3. However, during dinner time, it goes to $51. So people are spending more money during dinner. So is it different for male or female? Generally, female population spends less money compared to the male population, and that's correct for both dinner and lunch. The next thing we can do, just remember that we had the sex variable and the day variable and the time variable. So we can start making more graphs if we wanted to. If you were interested in understanding what is going on with the different days, are people paying more money for food on different days? We can add a row parameter and set the day onto the row variable. What it will do, it will make more rows in the series of plots. So like always, the columns will be time. So the left column will be lunch, the right column will be dinner throughout all the way. But the rows will be different days. For example, this will be for Thursday, first row. Second row will be for Friday. This is for Saturday. and Sunday. From what I can see, there is no data for lunchtime, Saturday, and Sunday. That's why it's blank. However, on dinner time, Saturday and Sunday, there is data and people are dining and people are spending good amount of money. Thursday dinner time, there were no males dining in, at least there is no data about them. And Friday night, Friday dinner time, there were males and females dining, but they're not really spending too much money. Males are spending up to $40 and females are spending up to $25. This is the type of plots you can make with Seaborn, one line code, and you can generate so many graphs. What I'm gonna do, I'm just gonna get rid of the days rows because we don't have a lot of data, so there is no point really plotting them. Let's go back to two plots at the same time. Let's go back to statistics about ECDF. You can have the proportion on the y-axis, so the proportion of the total. Say if there are 10 people out of 100, you will assign 0.1 because 10 over 100 is 0.1. So the ECDF will go up by 0.1. However, you can change the stat to count. It means that it's not going to make it on proportions, but it's going to make on the number of count of people. How is it different? Well, you can see on the lunchtime, the number of females and the number of males dining in were pretty much the same. However, for dinner, male population is way more than the female population. This is what we could not see with the proportions on the y-axis, but if you use the count, which is the actual number of people, not the fraction of how many people over the total, you can see this graph pop out like this. The other thing you can do, you can use the log scale if you wanted to. So by default, it is set to false, but you can set it to true. For this data, I don't think it really makes sense to use the log scale, but if you wanted, you could use it for other data. So I'm going to set it back to false again. So let's get rid of these three last parameters that I set, and let's go back to just one graph. So now I'm going to show you how to make this with the ECDF plot function instead of the DISPLOT function. So instead of using this parent function, I want to use the ECDF plot itself. So let's use sns.ecdf plot. The data is tips and x equals total bill and hue equals, is that sex? Yes, and hue is sex. So I am producing exactly the same plot, just a bit different in graphics, but trust me, it's exactly the same plot. It's just a bit skewed in vertical axis. So now I use ECDF plot to make that. I could just say, to make it look a bit similar, I can set the line width 4, and that's exactly the same plot. I hope you really enjoyed this video. If you did, please hit the like button, subscribe to my channel, and hit the bell to be notified when I post videos. Thank you.